Good afternoon, everyone. This is Chris Riley with System Source. I'm joined today with Dave Ferg, who's one of our senior consultants, as we delve into how you can successfully migrate to Microsoft Azure Cloud. So if you were with us last week, or on the 18th rather, we went over, it was kind of the first in this series, so that was the first part. This is the second part, but you can, no problem, obviously, you can attend either one or both. But the series that today's topics is a part of is really tied to that first one back on the 18th. And the name of that webinar was Alternatives to VMware to Avoid Their Massive Price Increases. So while we're not going to recap that webinar here, but we can certainly provide you with that deck as well as with the recorded webinar if you'd like to jot it in your evaluation at the end. Is that VMware and Broadcom have introduced a number of changes to their licensing and substantially higher pricing on their licensing, which is incenting lots and lots of folks to say, what are my alternatives? So on the 18th, we looked at principally on-prem alternatives to VMware. So if you wanted to stay on-prem, because that's where your VMware is, what were some of the alternatives? So some of the things we took a look at were Microsoft Hyper-V, looking at Azure Local, Azure Cloud, which we'll delve into today, HPE Essentials, which is kind of HPE's Hewlett Packard Enterprise's hypervisor. So we delved into those and a few other things back on the 18th if you're looking for kind of on-prem pieces. If you wanted to look at a cloud-based alternative, you're in the right place for today. So we'll be looking and kind of deep diving into the whole Azure Cloud piece today. We just touched on it back on the 18th, but really delved deeply in that one into on-prem stuff. So again, if you want the on-prem piece, just note it on your evaluation. Be happy to send you that recording link so you can watch that, as well as the deck for that session as well. So today we're going to deep dive into the agenda of looking at Azure Cloud. So we'll be looking at what are some of the best practices when you're migrating over to Azure Cloud. We'll look at things like why would you want to do it anyway. So we'll look at things like reliability, resiliency, manageability, fault tolerance. The perennial question that comes up when you start looking at Azure is, well, what about my Active Directory? So we'll delve into that one, look at infrastructure, as well as the, again, the always popular topic, which is how much does this stuff cost when I'm going to be consuming Azure resources? So we'll touch on that one as well. And then we'll have Q&A at the end, which I'll talk about in just a moment. So first things first, a little bit of housekeeping. So hopefully you have a pizza in front of you if you ask for one and that you're enjoying that. However, if it does not come yet, just be patient. They may be looking for your address. You may find a delivery driver in your lobby of your building. Perhaps if your front door is locked, check there, or wherever food seems to disappear in your office. But if you still can't locate that pizza, please just note Julie Dellinger's email address and just reach out to her. She'll be happy to give you a hand. All right, during the webinar today, so the audio is in presentation mode, so you'll be able to hear me and Dave momentarily. However, we can't hear you, but we do that just so that any noise where participants maybe don't come through the whole group. But you can reach me at any point during through chat or through the questions tab. So in fact, if you put in any questions that you have, just put them right into the questions tab. And we'll save those to the end for Q&A. I'll read those questions out to Dave and he'll be able to respond to them there. This presentation and the recording will also be emailed to you today, and there'll be an evaluation at the end, which you'll just get after the conclusion of today's session. And so if you can take a moment to just complete that, lets us know how we did, how we can do better. We try to make it fun by pulling one of the completed evaluations for a $50 Amazon gift card. If your home is like mine, Amazon rarely misses a day to deliver some things to us, and hopefully that $50 will come in handy for you. So that is at the end. There'll also be a number of resources, which I'll talk about at the end, that could be helpful to you. You can just note those on your evaluation. All right, just a little bit about System Source. We do have some new friends for System Source, as well as our long-established friends. We appreciate you both. So System Source, we've been around since 1981, about 70, 75 of us at System Source. And we meet a lot of customers where they first need to acquire technology. So while that can be in user computing side, Most of the work that we're doing is in the data center, whether that's traditional on-prem or cloud, so whether it's Microsoft Azure, Amazon Web Services, or all the other places that you could put servers, storage, security, networking, all those types of infrastructure. Those could be on-prem, it could be in Azure, it could be in Amazon Web Services, it could be in a colo center, it could be in our data center, it could be software as a service. Regardless of where that infrastructure and data lives, we can kind of help design, support, and implement those types of technologies. So people are acquiring because they need to improve. So we talked about just a bit on consulting and cloud services, but training is another big area with over 700 or 800 classes available at any one point, all available remotely. The whole Microsoft stack is available on there, as well as about 2 or 3 dozen other both manufacturer-specific training as well as technology general training. So you might find things like Cisco training, but you'll also find things that are more general like security. Present is professional AV, so all the digital signage, all the Teams rooms, WebEx rooms, all those types of facilities where you're going to be needing to put large displays, projectors, microphones, speaker systems, whether that's in kind of a built-in, in kind of a more sophisticated way, or or less so. All of that kind of work is done by our professional AV group. And then finally, we support all these things, either calls when things go bump in the night under service support, reactive, or proactive, where we're under managed services, where we are the IT department for many dozens of clients in this region. That's a little bit about System Source today. Do have a couple of upcoming webinars. So one is going to be by our Pro AV group on the 7th, and that's going to be talking about Microsoft Teams rooms and what the technologies and such and the considerations for those. And then coming later in October, we'll be looking at cybersecurity myths so that you can kind of understand that and help protect your organizations more effectively. And with that, I'll go ahead and turn things over to Dave, please.
Thank you, Chris, and thank you all for joining us this afternoon. I'm hoping to make this a valuable time for you with giving you some information about why you might want to consider Azure as the alternative to VMware. As Chris mentioned earlier, we did an earlier one on the 18th, so if you're interested in that, again, put that in the evals, and we'll send you that slide deck as well. That, again, talked about the on-prem. Today, we're going to talk about the cloud. Now, it's not one or the other. It's most likely going to be both, as you're going to have resources on-prem and in the cloud, at least for the foreseeable future. At least for many of our clients, that's the way the world goes. But our focus is on the Azure world and why you would want to be up there. At some point, maybe in the future, you could be all cloud. It depends on the performance and the type of apps you're running. So there is no right design or wrong design. It has to be the design that supports your business. So again, we're focusing on Azure. If you have questions about how to integrate some of these, put them in the Q&A. We can see about answering them if we have the time. But I'm not really going to spend a lot of time talking about connecting to the on-prem. A little bit, but not much. Okay, so before we start planning on doing a migration to Azure, we need to consider a few things. And there's a lot of migrations we have done that have felt spur of the moment, from the client's perspective, where they haven't thought it through as to what it is they're trying to accomplish. So I always want to start off with planning and making sure you understand what it is you're trying to tackle and what you're trying to complete, so that you understand what a end state should look like and whether we really got there or not. Migrations are opportunities to change your technology. We're going from what you have now to things that are new because the vendors are building to the cloud. So if these technologies are going to appear, they're going to appear up in the cloud first. You want to consider what resources you might want to move to platform as a service or SaaS, where you're going to have an application provided by the vendors. With that, into a decision like that, you still have to be considering your regulations, where your data is going to be, how you're going to back it up, what the SLAs are, especially if you're using SaaS products, because they're in somebody else's data center, but that's your data sitting there. So what's the authentication for that? What's the backup? What's the recovery for those things? So your planning has to, when you go to the cloud, your planning has to expand to things that may be outside of your direct control. You need to understand your internet and WAN connectivity and its capacity, because we're now moving things from on-prem, where you may have focused all your connectivity, to up to the cloud, and your users now have to redirect into which direction, to get to the location where the data is, so they don't have to make too many hops. So you just make sure you look at that and you have the bandwidth you need to be pulling files up and down, to be, to edit and things like that. So you're not actually hindering users by moving to the cloud. You also need to know from where your users are connecting to get to their resources. Are they sitting at home? Are they in offices? Are they working on kiosk machines? Are they coming to it through phones? Now, that's a lot of things there that you want to, we're not going to cover all of that in this webinar, or we'll be here till dinner. But you do need to consider where your users are coming from and how they're going to be connecting. So because we can have a wonderful platform in the cloud that no one gets to conveniently. So part of the planning is doing that. What is it you're trying to do? Are you trying to just save money? Are you trying to build more fault tolerance and flexibility in your environment? Are you trying to take care of new technologies? I would strongly recommend that you make sure you understand what your goal is. Make sure your vendors understand that who may be working with the migration or assisting you, what it is that's most important to you in your priorities and in the design, and making sure we're meeting those when you're doing that. So just don't assume everybody knows what the goal is here. Know your requirements regulatory-wise. Where can your data reside? What security is required in your environment? And again, your data may be in multiple locations now, no longer within your brick and mortar, but out in your version, your tenant within Azure, maybe in a second region. We're talking about multiple regions and replication in a little bit here, in a other vendors database, data center, like in a SaaS environment or things like that. So make sure you understand what it is you have to secure and how you have to secure it to meet your regulations now that your data is getting in more and more locations. Do you have existing skill sets to manage an Azure environment? Is training needed? Do you need additional staff to either perform the migration or to manage the migration after the fact? I would not think you would need it not so much to manage after the fact as you would need it during the migration, but it's possible, because you may be taking on new technologies that you do not have the skill sets for a while anyway, as you're coming up to speed and managing the new environment. What tools are going to be required to do the migration? And that will a lot depends on how we're going to migrate. So let's get into that right now. So as far as, and this is primarily going to apply to servers, that's where you'll most be able to visualize what I'm about to say here, but other technologies like SQL and things like that, this also can apply. Do you want to migrate as is? Take your database as is, your server as is, and just put it up into another data center, which just happens to be Azure? Or are you going to want to build new, either putting in new technologies or just have a chance to do your upgrades? And the first question you need to ask in that kind of design is, well, what are your time constraints? Because the as-is migration really fits the need for the need to move fast, because you're just going to replicate what you have and bring it up in another data center. To do that, you want to make sure your apps and OSs are current enough. You're not running 2008 or something like that. They're current enough that you don't need the upgrades. And you're just going to replicate them, make them put the new server into Azure and decommission the one on-prem. Another reason you might want to consider an as-is migration is you have a fairly complex environment with a lot of dependencies. And at the moment within the migration, you just don't want to be introducing changes. The other option is to build new. And if you're thinking of a virtual machine itself, this is where you're going to be upgrading the operating system and apps, and you're ready for a cycle of operating system upgrades anyway, so why not do it in Azure as opposed to on-prem on another VM? Those migrations will look very much like they do today, in that you would build a new VM, put an OS on it of all of this, and then you would just file migrate or printer migrate or whatever it is. It's just that the new VM is now in a different data center than yours. So that's what the build new looks like. This was also your opportunity to modify configuration. So if you want to go to a platform as a service, this would be, instead of having a SQL server, you're just going to use hosted SQL and put your databases there. This is where I want to consolidate from 3 servers to 1, or expand from 1 server to 3. This is your chance to make these changes. The build new has been the most common method that we have found our clients using. Now, what it means, though, in the migration is it is actually going to be a series of sub-projects. It's going to be the most flexible because you're migrating components as opposed to migrating everything at any one time. It does require more time. It can allow you to introduce new technologies, but may require multiple tools, multiple vendors, and treating each project, each component as a separate project. For example, file migration, that's fairly cut and dry, but it's one task. But maybe you have an accounting app that needs to move, and you want to bring in your accounting vendor to do the software aspect of it, though you may be doing the server aspect of it. So we need to be dealing with coordination of multiple little projects all wrapped within the one big one. But it is the one that will get you to the latest, greatest. So if you have time during the migration, moving new could put you in a position where you're more flexible as a business moving forward because you're taking advantages of new things. I will also say it's not one or the other. If you ultimately want to be taking care of new technologies, but you need to move fast, well, then just move as is a perfect strategy to get started. Get it up into the cloud to get off your VMware platform or whatever your on-prem platform is. Now start looking at changing the technologies piece by piece when you've lost that deadline that was on you at first that would cause you to move quickly to move to the cloud. It also could be a combination of some servers you've just upgraded and you like them as is and you don't want to change them, migrate those as is. And other things, let's say your SQL, you want to move from a SQL server to a SQL platform. So you do that as a build new model, and some other servers you do as an as is model. So the total migration project itself could be using different strategies depending on everything from the time to what it is you're trying to do in the target environment. Maybe your target environment is going to be far more fault tolerant and robust and replicated than your on-prem environment. So we need time to build out that cloud environment and then put the resources in to take advantages of these things. So when you're planning these things, we want to go through it, even though you may be planning to do all as is or all as build new, we really do want to look at it component by component. How do you want to handle files? How do you want to handle backup? How do you want to handle authentication? How do you want to handle connectivity? And put these pieces together so that at least all of the components are aiming at the priority that you have, whether it's cost savings or more flexibility. Everything we build in the new world and how we get the data to it is all going for that same target. That's where the planning really comes into play. And that's, unfortunately, that's the one that gets the least attention, because at the end of the day, you can't turn around and say, well, here's what we've done today, because all you've done is plan on doing something. It's very helpful because a lot of projects can wander left and right as priorities change or as people's understandings of priorities are different. So it keeps you on track, keeps you moving along, makes the project more unified in what you're trying to do. So enough of that. Okay, so let's move on. So if you want to migrate as is, now Dennis talked about this on the 18th. I'm just going to reference it and move on. The as-is migration tool that Microsoft gives you is the Azure Migrate. It is a tool that allows you to replicate your current VMs or databases or web apps or other things these things are what it can migrate. It allows you to replicate them up, verify that they've migrated properly in a test environment, and then do the final cutover. The migrations using the as-is tool have very limited downtime to them in that it has replicated the server. When you pull the trigger to go, it's just going to do a final sync of data and then switch the new one to be the priority and power down the old one. So minimal downtime, not zero downtime. The build new would depend on how you have to do that. I don't know what the downtime would look like for that because it would be different for everything. But the Azure Migrate is a tool that's available to you for free within some time constraints. So there's also some other third-party tools you can use, and Dennis used this slide in his as well, that each have their advantages and disadvantages, features of one that are not in the other, et cetera. Worth a look through to compare to the Azure Migrate to make sure it's going to do what it is you want it to do. So I would at least do some research for yourself on tools as you are preparing, and just compare it to what you're going to get with what you already have in your Azure subscription. All right, so let's talk a little bit about why you would want to migrate to Azure. And in this section of the presentation, I'm going to be talking about primarily why would you move for security reasons? Why would you move for fault tolerance reasons? Why would you move for cost management reasons? I will say right out of the gate that moving to the cloud does not mean you're saving money, does not necessarily mean you're spending more money. And a lot depends on what it is you're going to build up in Azure and what features you're going to take advantage of. What it does mean for most people, though, is you're moving more to a monthly or yearly bill as opposed to these big capital expenses that you get every so many years where you're replacing hardware and doing major upgrades. So I will also note that now that you're in Azure, if you've migrated already, that does not mean you're no longer doing Windows Server upgrades, because if you're doing with VMs, if you have virtual machines up there, they're your virtual machines running Windows, and you'll still need to be upgrading them. If you are moving to platform as a service, meaning again, a SQL service as opposed to a SQL server, there you're not worrying about operating system upgrades. And that's true also in the SaaS environment as well. You're not responsible for that. But in the Azure world, is an infrastructure as a server platform, which means it's putting your resources in there, and then you have to manage them. It's just giving you the infrastructure on which to live. So one of the advantages, if you will, features that are attractive, is the fact that this is a global network that is connected with 60+ regions. Each region can have multiple data centers in it, all connected together for replication, and each region has its own replication partners for where they have some very high-speed connectivity that say you could do geo-replication of your data. If you want to get information about the security that's built into it, whether it meets your requirements, that your regulatory requirements for security and things like that, Microsoft does have a trust center that will let you know how they meet privacy standards, compliance standards, things like that. So you can generate your reports to management to say, if we go to the Azure platform, here's what the security has already done for us as far as just being on these platforms. Then there's things you need to do to meet all of those as well, but Microsoft gives you the tools to do what you need to do, to build what you need to build. All right, so this redundancy and flexibility are probably the two things that Azure really brings to the table compared to an on-premises environment, where many people do not have. They may have a DR site in another office, they may have another office in which they're replicating some SAN traffic and things like that. But Azure steps that game up a little more than most people have in their own environments, because they have spent the billions of dollars it takes to build the infrastructure that virtually none of us would be able to afford to build. Now you're just going to be able to use their infrastructure for a fee and not have to build it. And when we speak of flexibility, that's one of the great advantages, is that you are not having to implement the technology. You need to just incorporate the technology into your environment. So a great advantage of thinking of the cloud. Okay, so each region, as you can see in the little diagram with the blue dots, they have regions, have multiple data centers in them. Well, potentially have multiple data centers in them. Not all regions do. Data centers then are considered availability zones. So within a region, there could be multiple data centers where your data can be replicated across. You can put VMs spread across different availability zones that would protect you against data center failure. So if in your environment now, if your data center went down, you may have another data center you could go to and you would have to do a failover. That's what the availability zones here for Microsoft, except you can build it such that there isn't, it needs to be a failover. We'll use replication to keep both running. So you're protecting against not only a machine failure or an application failure, but all the way up to a data center failure. That's what an availability zone is there for. Some regions may have 3 availability zones in them. Some may just have 1. And we can build replication between them to replicate your data. Now, there are built-in regional pairs where you want to replicate your data if you can. These regional pairs are miles apart from each other, so they're protected against power grid issues typically, depending on the regions you pick here. But this will give you now geo-replication so that you could have data center failure protection, region level protection. Of course, this does not handle the DR aspect of getting your users connected back in. You need to make sure you plan that as well. We're going to talk about some tools that will help with that. That's why you would want to move to Azure. But we have this built in already. The availability zones, that replication is built in already automatically. The cross regions, all you need to do is check a box and that replication will be done for you. So it moves pretty quick. Understand that when you replicate across regions, you're now taking up more storage and having bandwidth of replication. So there are some costs to moving geo replication, but it is there for you to use. Each region is always paired with another at least 300 miles away. So if you have a requirement to keep your data in Europe, for instance, there will be other regions to replicate to, or in the US, such that your data will not leave your regulatory area. Let me get rid of that laser out of that picture here. Now, what you're looking at on this screen here is a screenshot of creating a virtual machine. And one of the things that you can choose is if you want this virtual machine to be put in an availability group of your choice, or you can leave it as Azure chosen as to where they would put your virtual machine. If you choose that you want to select the availability zone, you then can select the availability zone or zones that you want your virtual machine to be in. Now, some services, for instance, the Azure Load Balanced service, is automatically replicated across all zones. You don't need to worry about selecting that. VMs are availability zone only. They live in one only because it's one virtual machine. If you have multiples selected off, this you're making replicas of your machine, not for replication of data, but it's going to have that machine replicated so that you can now use it for fault tolerance purposes. So again, some services are locked to an availability group. You need to then manage any data replication, between those types of resources. Others work across all availability zones automatically. For instance, the load, if you implemented a load balancer, it would just automatically be in all the availability zones of your region. No need to worry about it. If in a failover, it still lives there, okay? Okay, probably should have clicked that one. So again, you picked the availability zone. So redundancy is immediately available to you. I will note that if you do replicate or do create a VM with multiple availability zones, you're going to be charged for a VM in each one of those availability zones. So there is a charge for that. So let's just talk about some of the network security that Azure gives you. Now, we have done entire webinars on this slide, so I'm not going to delve into it greatly, but I just want to point out some things that become available to you just by being in the cloud, and helps you maybe redesign your infrastructure to be more of a best practices approach if you don't already have that on-prem. So VNet peering, let me explain what that is here. Up in Azure, when you have a subscription, you create a virtual network. A virtual network is a IP address range that is yours. All right. Within that, you can carve out subnets out of that IP range. And within the virtual network, these subnets can communicate with each other by default without you having to configure anything. Now, we'll talk about in a minute where you can block if you don't want things to go between certain subnets or only one particular protocol go between. But by default, everything in the virtual network communicates with themselves. But it does not, by default, communicate with other virtual networks. So, but you can VNet peer, which means now all the traffic, over here on VM01 can now talk to VM05. Just because the VNet peer is there and the routing has been built in with Microsoft to make that connection. No VNet peer, these two don't talk by default. Okay. If you want to not peer with another VNet but still want to have access, you can build something called a route table. You're probably very familiar with them. This is basically all right, if I'm here and I want to get to this, if I'm here and I want to get to here, go through the firewall. That's the next hop type of thing. And now, let me page up a minute here. Now subnet 2 here knows how to get down to this, maybe an isolated subnet that you wanted to deal with. It's keeping it protected. And in fact, anything in subnet 1 knows how to get to subnet 2 and know how to get down to the firewall. In the diagram here, though, I didn't talk about it. This particular subnet, VNet, has a virtual network gateway installed on it in the diagram, which supports site-to-site VPN connections, point-to-site for your end users. Users or offices can be connected into this VNet. This route table then would let them find the specific items here. So I can control the flow of traffic with things. All right, I already had that one up here. If you want to block or allow any certain protocols, you can build a network security group. You think of access control list is what you're thinking about here. Source, destination, IP addresses, ports, all kinds of filters that you would put on a typical access control list. It has a default deny at the end of everything. It has a default allowing of a load balancer to work across all VNets, so you can spread things across VNets and still have them work as a unit. It allows by default any virtual network to virtual network communication with the peering enabled, and then anything, these are your lowest priority, bottom of the list, and above that you just put in anything you would normally in an access control list that you would want to allow into or out of that subnet or machine. And I say subnet or machine because you can create a network security group that is linked to a subnet, and it would apply to every virtual machine or resource within that subnet. You can also take a network security group and attach it to the network card of a virtual machine itself. So in this instance here, VM1, if you wanted to get in, communicate with VM1, you would have to come through NSG1, Network Security Group 1, and all its filters. And if it allowed traffic to come through, then there'll be NSG2 that would get processed before it got to the VM. Whereas VM2 is only going to process the network security group attached to the subnet. VM3 has nothing attached to its subnet, would only process what's attached to the NIC itself. So I can be very specific. General rule of thumb, you put an NSG on your subnets, you make them broad that would apply for everything up underneath of it, and then you put a second NSG behind that for the very specific machines on what you wanted to lock down. And these are just resources that you can just say, create network security group and put in your filters, and you can build your routing securities that way. Firewalls. Azure has full-fledged firewalls for you to use. Quick sidebar here. Azure has a firewall, comes in 3 platforms, basic, standard, premium, different features. We'll talk about that in a second. But in the marketplace, if you are a SonicWall place or a Meraki place and you want to have those kinds of firewalls in Azure, they're appliances, right? You just get the appliance from the marketplace, and whatever the purchasing is of that, licensing and all that from the vendor, you pay that to the vendor still. And the only thing you're paying for Azure there is the use of a resource, the CPUs and the RAM and things like that it's using. So if you like, I'm going to say Meraki for discussion. If you like Meraki firewalls on-prem and you want to have the same thing in the cloud, you can use that as well. You do not need to change security platforms. That's also true with those, I won't back it up, but that virtual network gateway appliance that I was talking about, creating VPN connections, that can be your Meraki or your SonicWall or whatever it is that you want to have in the cloud. So that's available to you as well. So you can keep continuity between your on-prem. Maybe you have 6 offices all with Meraki firewalls and you don't want Azure to be different. Well, it doesn't have to be. It can be part of that as well. The firewall comes in three SKUs. And again, you pay more, you get more. The most advanced gets more of the advanced threat protection pieces. The middle one, standard, gives you more web content filtering and proxying capabilities. And then a full, the regular firewall features. We've done, again, a webinar on the firewall itself before. We could pull up for you if you're interested in that, but it talks about how to handle NAT translations and handling encrypted data coming through the firewall, et cetera, because it has all those features built into it. So there's a firewall for you to deploy if you want, or you can use the brand that you like now. Private endpoint, that's an interesting one. By default, Azure resources are accessed using public IP addresses. Now, that does not mean they're wide open to the network, to the internet, but that's how you access them, through a public IP address. And then there's security that keeps it from just being accessed blindly out there in the world. But if that's not good enough, if you want to stay off the public IP address, you can add something called a private endpoint. Think about it as a network card almost. That's kind of a network card resource that you attach to a Azure service that would normally be connected to a public IP address. And it now is being given a private IP address. So if I have blob storage out here that I want VM1 to get access to, well, VM1 knows how to get to subnet 172.31 because it comes through the VNet, across the peering into this VNet, finds the private IP address that is associated with that storage. There is a DNS change that allows that to happen without changing the DNS name of the blob storage. It will still be accessed using the DNS name it would have if accessing the public IP address. But the DNS changes in there through CNAME records allow internal devices to access it through private IP addresses, and your traffic stays within your world and never leaves and goes outside of that. Expanding that out to the VPN connections from, if you have an office, comes across a site-to-site VPN, it would hit this VNet that you're seeing in the diagram, crosses over the VNet peering, hits the private IP address, and gets to the storage. Nothing's left your world. So private endpoints allow you to take Azure services, storage as in this example, and other things, there's a whole list, and access it through your IP address schemes and not Microsoft's. Here's another diagram of that. Basically what this diagram is saying, kind of what I was implying, it takes the public IP address that would normally be associated with it, and you can eliminate that completely or bypass it if you didn't want to, and only allow access through the private. So that's the only way you get a hold of that resource, meaning that your end users on premises don't need internet access. They just need WAN access through VPN or whatever to Azure to gain to your access to your storage. So an office that is isolated from the internet, but can still have a VPN connection out or some other method of connecting to Azure will still access to your world here. So private endpoints is another one. And there's also things called service endpoints. I don't have a slide for it, but I'm just going to put it out there. Same concept, except it continues to use the public IP address, but doesn't allow it internet access. It has to stay in the Microsoft network, not necessarily in your address range, but it stays in the Microsoft network when you make those connections. And that allows you to get to services, Azure Platform Services, without having to go an internet connection on there. All right. Key vaults is another one. Passwords, certificates. In fact, let me just pop the next slide up here. Certificates, secrets like your passwords and things like that can all be securely stored in a key vault that is role-based access control, so only user A can access secret B, etc. And you don't have to put the password into any authentication string or anything like that. You just access a storage event. Let's say you access a Azure resource, let's say storage. And if it's going to require a key or a secret, keys for like encryption or a secret or something like that, you just ask the key vault for it and it will pass it over to the device. So you can securely store all your secrets, keys, and certificates and all of that in a key vault. And then that way you're not passing credentials around. Best practice, and I'm going to have to pick up my pace a little bit here. The best practice when going into Azure is you want to create a hub and spoke design. So you want an entry VNet where you would put that VPN gateway, that firewall, anything that touches the internet, and something called a bastion host, and I'll talk about that in a second. And then let that connect out to your VNets where your machines are. So now you've created a central point where all outside connections will be vetted before it hits your inside world. That's best practice in design. The bastion host, again, by default, all resources get a public IP address, which you can take away, but that's what it gets by default. When creating a virtual machine, it will ask you if you want to enable the RDP connection to it. And if you do, it will enable it on the public IP address. Well, the bastion host lets you take that away so that you can make a 443 connection to this service running in your hub, and then it will proxy over to your VM. So even your RDP connections to your servers to get to the console screens are protected through 443 encryption, and you're not opening up RDP. So we have that kind of security available for you. Network redundancy. Let's say you have a network that crosses many regions with web servers in the east and web servers in the west. There's something called a traffic manager, which is a DNS service that will direct people to wherever the resource needs to be. You make a query, the traffic manager responds based off of your geography and other rules that you may set, responds back to the client and tells them where they need to make their connections. So if you have things in the east and things in the west, there's a traffic manager that lets you balance them out. Application gateways. These are layer 7 SSL offloadings that will front end anything that you want to have web access to behind, and it will start the filtering process, which could then lead into the firewall, which can lead into the back end pools. So inbound would be your application gateway that you would use to filter traffic coming in to gain access to your services. And of course, there's load balancers so that I can install a VM in every availability group in a region and then load balance between them so that if any data center goes down, I still have potentially 2 others still running in the region. And it will have a public side that will receive. And in this diagram here, it's saying, okay, we can load balance into the web tier, and then you can have just an internal one that load balances into the back. And putting them all together, you get a typical Microsoft document. You have a traffic manager, which could go between 2 locations, depending on my location or any other rules I may set. Both regions could be front-ended with an application gateway, which does the initial vetting. and proxy, back into a firewall, which continues to vet, to a public-sided load balancer that feeds into the web tier, to an internal load balancer, which feeds into the back end. So we can secure, that's the left-hand side of this, and we can build fault tolerance, which is the right-hand side of that. So these are the things we can do with these resources. Now, of course, you pay for traffic manager, application gateway, load balancer, and things like that, but they're there to deploy, not as simple, but as with a click of a button. It's not that simple, but you know what I mean. Storage redundancy. Each data center stores your data in 3 locations. When you go to store a file, there's going to be 3 locations within that, across racks within the data center and between servers, and you get 3 copies of your data by default. If I choose so, I can say, okay, my 3 copies of the data, I would prefer 1 copy to be in each zone of the region. So if you're in a multi-data center region, you can do zone redundant storage so that your data is data center failure protected. Geo redundant storage means I'll have my 3 copies here, and I will replicate to the partner region, and I'll have my storage on the other side. Now, geo redundant will have additional costs because you now have additional storage and you have some traffic going across, but your data is replicated for you already. Your Azure backup software will geo replicate by default. So your backups will leave the region of which it's backing up and be stored somewhere else as well. In storage security, and I'm going to bang through this one fairly quick, in addition to data encryption, which I'll talk about in a second, your storage has role-based access control, so you can control who can access it and what privileges they do have access to. There's that replication that you can configure, how you want your storage replicated. Whether you want anonymous access enabled or whether it needs to be authenticated access. Data retention is built in other words, you can do recycle bin type of work, either at the blob level or at the container level, container of storages accounts. Versioning is available in your storage. As you can see, these are some of the things that you can turn on and off when building into this section here. Network access, whether you want, I'll pop up the next screen, whether you want to use private endpoints, whether you want to enable access to your particular storage from any network in your world or just from very selected virtual networks or IP addresses. And notice under the public, I can say, nope, disabled. I don't want any public access, and then you have to create a private endpoint to gain access to it. So I can protect the source of the access to the service, plus the role-based access control, plus the encryption, which we'll talk about in a minute here. So let's talk about encryption. Again, let me get that off the screen. Your data is encrypted in transit and at rest. That's the standard they put out there since day one. In transit, there's client-side encryption, meaning if you're encrypting your traffic at your client, it will be encrypted in the transit up to Azure. Data link layer encryption is done between their data centers. So when your data is moving between one availability group to another or one region to another, it's already it's encrypted for you already. You don't have to configure that. And you have TLS encryption between Azure and customer sites by default in there. So everything's encrypted there to get it up there. At the storage location, you have server-side encryption. So the storage accounts in Azure are all encrypted. They're encrypted with a data encryption key or disk encryption key, which is encrypted with a key encryption key, which you could either let Microsoft, their platform, rotate the key encryption keys for you, or you can do that if you want to manage your own keys. So you can do customer managed keys, which is managing the key encryption key, which encrypts the data encryption key or disk encryption key, which keeps your data encrypted by default. And again, by default, it's publicly managed, and just creating a storage account sets up this path here that I'm showing. Server-side encryption is also known as service-level encryption. I just showed you one that was encrypting the blob storage. When creating the storage, you can also turn on infrastructure level. So the infrastructure on which your storage is, the infrastructure on which your encrypted storage is going to be located will also encrypt. So now you have a double layer encryption if you wanted to do that. That one is only managed by Microsoft, and as far as keys go. And configured at creation, that's the only time you can do that. Managed disks, these are the disks your virtual machines will use. These will be encrypted by default. They are basically just an abstraction of a page blob storage, and a virtual disk file. That's what a managed disk is. This is your C drive, your D drive, your E drives that you've attached to your VMs. Since they are on a blob account that has blob storage, they will be encrypted because it's just on a storage account. So by default, even your managed disks are encrypted because they live on an encrypted storage platform. If you want to manage the keys for managed disks, you have to use something called a disk encryption set, which is to think of it as a container. Think of it as a container which has a disk encryption key assigned to it. You then manage the key encryption key yourself by putting it in these key vaults that I told you about before, but now you get to rotate the key and the security on that key yourself. And then to encrypt the managed disks with your keys, you just put them in the container and they'll be encrypted with the keys that you are managing on that. So the disk encryption set encrypts the managed disks only. These right here. That will make sense in a minute here when I go on to the next one here. Another method for encrypting the disks attached to your virtual machines, in other words, managed disks, is you can use the BitLocker or the cmcrypt for Linux so that the OS is doing that. That's called the Azure Disk Encryption. The keys are stored in the Azure Key Vault that you have enabled to do that, so that when the disk needs to know its key to decrypt the BitLocker key, it's going to go to the Key Vault because there's an extension on the VM that was installed. It will go to the Key Vault, get its key, so it can decrypt itself and move on. So that's another way. It's going to be BitLocker based with the keys in the Key Vault, and that allows you to encrypt your managed disks that way. Right? Because it's being run by the OS, you can encrypt the OS disk, the data disk, and any temp disks that are part of the machine. You can, and again, that may make sense with the diagram that's coming up. You'll see it graphically. Data then is encrypted before it is sent to the storage account. Why? Because it's running on the Windows OS inside the VM. And then when it goes to write to its disk, well, that's going to travel across Microsoft's network to get to the disk. That data is now encrypted in transit with this encryption, in addition to the site-to-site stuff. So again, so you've seen this before, customer managed key versus platform managed key for your managed disk. So this is your D drive of your VM, if you will. That VM is running on a host. This is the encrypted disk, the managed disk. That's not the temp or cache unless I wanted to do that explicitly. So these disks, temp and cache, are not encrypted by default, and neither is that transit over here until it gets down to the disks and then it's encrypted. That's one way to do it. With server-side encryption, the temp and the cache are not encrypted, as I just said. The path from compute to storage is not encrypted. But if we can also then enable encryption at the host in addition, which means we're going to start encryption over here as well in addition to that. So the data stored on the host is encrypted. That's the temp and cache. And the data flow, since it's encrypted here, all of this would be encrypted down to the managed disk. The temp disk is encrypted with the PMK, right, the platform managed key, and the cache, which is the cache of the managed disk, is encrypted with the same key that the managed disk is encrypted. So there's no decrypt, re-encrypt that's going on there. So it starts on the host, so its transit to storage is also encrypted. So you notice now that your data is being protected all along the path here. Just by going up to Azure, I can choose easily where my data is being encrypted, how it's being encrypted, how the keys, all this stuff is probably in addition to what you already have on-prem. So now you're getting some additional features available to you. And I'm not going to spend any time on this one because you'll get the slide, but here's just like a comparison of when I would want to use one versus another. With virtual machines, we can manage patching through Azure through either an automatic update or Azure orchestrated update, or I can turn them off and say, I want to manage it through my tools. The network security for a virtual machine, think of network security groups, firewalls, things like that. The disk encryption is part of virtual machine security because you are securing the data on it and where the keys are. And of course, backup. What about my Active Directory? And I think I have way too many slides for this. Sorry, but so we've gone over this before. But so let me just jump ahead to this. All right. You have an Active Directory on-prem. One of the things you can do is extend your Active Directory to Azure by just putting virtual machines in Azure that are your DCs connected across a VPN connection. All you've done is add them to another data center, if you will. This is a very, very common configuration. All we've done is added a data center, same Active Directory as you have on-prem. If you synchronize your Active Directory with Entra, like you would for Office 365 or anything like that, you could then enter something called Entra Domain Services, which is a second Active Directory domain managed by Microsoft. It manages the domain controllers, and it gets populated from Entra ID. So you have your Active Directory account that you create, it gets synchronized with Entra, it moves over to those domain services. And now if I want a virtual machine that's domain joined and it needs Active Directory because it needs Kerberos or LDAP or things that are Active Directory based, my AD account, because it was replicated over to this domain, coming across the trust, can access these machines using a different domain than my normal Active Directory. Now this for Microsoft is considered an interim step because they want you to move to services and applications and things that are using Entra credentials and not Active Directory. But this lets you start offloading out of your Active Directory into cloud-based world that's managed by Microsoft for your Active Directory. So costs. And again, I apologize, I just did not plan well to my timing well on this one. All right, so in the Azure console under the billing here, you can take a look at your costs. You can set alerts, budgets, and get recommendations for how to save money while you're up in there. The cost analysis gives you a running total of how much you're spending within a billing period, what is using that. These are color coded, so you can see who's spending most of the money. And these could be either individual resources or groups of resources that you have bundled. And you can see who's doing the spending. This may help you with chargeback. You tag your resources and then you bundle the tags together so that they report similarly for budgeting purposes. So you can maybe charge back or at least know where your expenses are going. You can change this graph how you like, so you can see it in any way you want to see it. By profile, by charge type, by cost application, et cetera. So you can see how the money is being used as you're using your resources. Cost alerts. These are actually coming off of budgets, which I'll show you in a second here, but these are the alerts that when I've reached some threshold in these items here, there will be someone who's being notified. And you could have a warning threshold, and then, you've exceeded your budget threshold, not that it will shut anything down, but someone's at least aware that prices are running a little faster than you anticipated. And again, this is how you would set those alerts, and you set the thresholds and who you're going to notify in that. Budgets are the budgets that will trigger the alerts. And you can get from the main console here, you get a running total of where you're sitting, whether you're green or red on anything. And you can find out where your spending is. You're going to get a bill, and it's going to be hard. And if it's become more than you expected, at least this gives you an idea of where to look. And maybe you've either under budgeted, or something is being misused or misconfigured or something like that. All right. And this is how you set a budget here. Again, how long, amount of money, when to trigger, et cetera, and things like that. And of course, there's an advisor. If you're There's a security advisor as well. This is a cost advisor, Microsoft's list of recommendations that might help you save money on your budget. And you click into each one and it will tell you, here's what's being spent. Here's what you could do about that if you wanted to change how it's being built. And of course, you're going to have to make a decision as to whether that affects other things as well. And so that's kind of it. I'm going to hand it to you in a minute, Chris, but no, real quick, we talked about planning. Make sure everybody's on page with that. Whether you're as is versus building new or both. Why Azure? Well, because there's networking and security redundancies built all through it at every level and in every location. Your storage is replicated all over the place, and you can build security into that, and setting your permissions and source locations and things like that. Your data is encrypted at all places and can be encrypted even more when you enable some other features. We talked about virtual machine security, and we talked about what to do with Active Directory, and then cost management. And again, apologies for moving a little quick at the end there. Just wanted to give you a lot of reasons why you might want to consider moving to Azure. And with that, I'm going to hand this back to Chris real quick.
Thank you very much, Dave. Lots of information to be considered as we consider migrating to Azure. So one slide, which you'll see in your deck, are some Azure-related training courses available through our Learning Center, and there's discounts associated with those. So if it's something you want to use as kind of either preparing, or if you're already in that world for better managing, you can certainly take a look at those classes. We did have one question, which we'll go ahead and respond to that person afterwards in respect for your time. And once again, thanks to each of you for spending the last hour with us. Thanks to Dave. And we hope you have a great afternoon. Thank you very much, everyone.